So I've had this idea for a couple months now where I create a fully functional crossbow using only laser cut and 3D printed parts. Aside from fasteners, the string, and the actual crossbow bolt that it's going to fire. Everything else is going to be laser cut and 3D printed. Today I'm going to start that project, take you through the entire process, and see if it's possible and how good it works. Before I start designing the actual body of the crossbow, I want to figure out my triggering mechanism first. And there's a couple ways I can achieve this that come to mind. So I'm going to show you those. I already have in my head which way I think I'm going to go, but I'm going to show you three possible ways we could trigger the crossbow. So let me show you. So option one would be a pull release style. So we'll call this rectangle the body of our crossbow. We've got our bowstring coming from the front arms, going back. Then our arrows in here. And we could have a pin that's holding the bowstring under tension, and then just a grenade pin, so to speak, where you just pull that down and it releases the potential energy of the crossbow. So that's option one. Option two, we have another crossbow body here. We have a pivot point and a lever here. Got our bowstring coming in, and it goes into this notch that I drew. And then it's attached to a trigger. So when you press the trigger in, it pushes the bowstring up out of the notch, releasing the potential energy of the bow. That's option two. And then the third option is kind of a little bit more advanced version of this. So I'm going to draw the trigger group first. So we have a trigger that has a piece going back and a pivot point. We have a sear here with a pivot point, and then we have a spring attached to it to return the trigger to its normal position. And then we have a little notch on the sear. And we have a half moon shaped piece here with a pivot point. Then we have our bowstring coming in. It catches this. So when you press the trigger, it pushes up on the sear, which drops the back, releasing that so that it can roll forward, releasing the potential energy of the bowstring. So that's option three. So this is the method I'm going to go with, and I'm about to take this apart and show you how it goes together. And I'll just do a quick dry fire here to show you how it releases. And yeah, I'm going to take this apart, show you how it goes together, and then we can build a final version of this in Fusion so that I can print the parts, and then we can start building the body of the crossbow around the dimensions of the trigger assembly. So here I have the parts that I printed for a test. This is just a test frame to make sure all my parts are working in unison. So we're going to assemble this, and I'm going to show you how it works. So first we'll drop our trigger in onto its pivot point. Then we'll take the sear. First, I'll attach the spring down to its keeper, and I'll put this on its pivot point. So I already got a mechanism starting to form. And then we'll put the string release up here. So now if I take this piece of string that I attached to this spring as a test and fit it on the string release, and I press my trigger, it releases the string. And you could imagine this as the bowstring. And then to reset it, you just do that. So that would be pulling the string back into the cock position. It resets the trigger. And now that I have a prototype / test build working for the trigger mechanism, I'm going to take that model, which I made off camera a couple days ago. I'm going to take that and adapt it to a finished version with an enclosed case and all the mounting points I need for this to work on the crossbow. And then I can jump into the body design and the limbs and the other components that need to be built. So I just finished designing what I think is going to be a solid prototype of the trigger mechanism and its enclosure and all that. So I'm going to get those parts printed and we're going to see how everything fits together, if we need to make any changes, and then maybe we can move on to the next steps. So I'm just using some screws here to get a feel for the fit of everything. Ultimately, these are going to be pins or bar stock or something. Right away, I'm already seeing that I need to make these screw standoffs bigger. The thermal expansion caused those holes to get quite a bit smaller than I want them to be, so I need to size them up a bit, and I got plenty of room to do that, so that shouldn't be an issue. But for now, I'm going to test fit all the trigger group stuff. So I've did a test assembly of the trigger mechanism, and I've got a couple issues that I need to work with. So let me take this cover off and show you. Well, actually, I can show you the first one. So first of all, the trigger, or the string release is it's not dropping all the way, and I'm pretty sure that is because this slanted area here, one of the lobes is binding against that, so that's an easy fix. The next thing I noticed is my screw holes to put the two halves of the shell together shrunk in size due to some thermal shrinking or thermal expansion of the pieces while it was printing. So I need to size them up a bit so that I can actually get some screws in there that are going to fit. It's going to live like this. I have these screws through it now to hold everything in place, but I'm going to use brass pins, I think, to ultimately hold the firing group, control group in. And I think that'll be better because I can put them flush with the side of this. So when I drop this into the crossbow body, there's no need to carve any space out for screw heads because they don't need to be screws. So I'm going to head back to Fusion, make these adjustments, print this again, and we'll see if we can resolve these few issues. Once I printed and got everything right with the initial prototype, based on that white shell that I showed you guys earlier, I decided to do away with the three-piece setup, and I decided to combine that top rail piece right into the shell so that that is integrated into the whole design rather than this being a separate piece. That makes it quicker to print, easier to assemble, and a lot less hardware to assemble it. I also increased the height on this a little bit to get the crossbow bolt up above the notch of the string release, and I made some adjustments to the internals as well, which I'm going to show you in the next video clip. Here is our parts assembled, but like I mentioned earlier, this is able to release without the trigger being pulled, and I just think it's due to the way it's locking. So I made some slight modifications to this, and we're going to replace those now and see if it makes a difference. All right, that'll work. So let's get this one in. And ultimately these screws are going to be replaced with pins, but for prototyping this has just been the way to go. I'll just spin it a couple times to cross thread it so I can let it spin free. Alright, now let's do the string release. This should be a lot more straightforward than getting that spring in that trigger return. I already think this is going to work better. Alright, let's put it together and see what happens. And if this works out, then we can call this trigger mechanism finalized and move on to other stuff. So another problem I was having in there that I may have mentioned earlier is the back of this was rubbing on the screw hole for the back. So I want to fix that. Or I wanted to fix that, so I removed a little material from that, and that should help a bunch. Tell you what, it's pretty satisfying seeing an assembly designed in Fusion then physically go together and work. That is what I wanted to test, and that is not failing like it was. So now the only way that's going to fail is if the mechanism shears inside under load, and that will be something we'll figure out when we test this, which is actually what I'm going to do next. Now that I know that this is working, it's binding a little bit, I'll fix that, but I'm going to put this on a test mechanism with some springs, running some string around this, and see how it all works. Now that I know the trigger mechanism is working the way it's supposed to, it's time to cut up some of this metal bar to make some pins to replace all those screws. Okay, I've got my pins for this trigger frame. They're going to need to be cleaned up, but they should do the trick. I'm going to tap them all in and see how it works. There we go. All right. So all of our mechanical parts are in there. Trigger is doing its thing. I just got to close it up, and I'll probably file the sides of the pins down a little bit so that it goes together a bit more cleanly. Now that I've got the pins secured in here, I've got them pretty well flush to the sides of this. I just designed a quick test frame that's going to kind of mimic the shape of the crossbow. I'm going to cut it out of plywood or MDF, whatever I have laying around, 1/4 inch thick, and assemble that. I have a slot that this is going to drop into, and then I'm going to use some springs similar to the spring I used in here to put tension on this string release, and then we'll test it out and see if it works the way it's supposed to. Got some scrap Baltic birch. Hopefully it's long enough. These are all my test frame parts fresh off the laser. So let me show you how this is going to work. So this is mimicking the limbs of the crossbow, and then this is going to mimic the body shape. So what I plan on doing is attaching this all together with glue, and I doubled up this part so that it had a little bit more rigidity. So these will go together like that. Then my trigger assembly will drop into this slot I've cut here. So it'll sit all the way in there. Then I'm going to attach a screw here and a screw here, put a return spring on each of those screws, and then tie some string between those two return springs so I can pull it back onto the trigger mechanism, and then that will simulate a load on the trigger assembly. So we'll see if this works. This is all theoretical until I try it. Now I guess we just wait for this to dry and see if everything fits. So fortunately for you guys, that's going to be just like this. I'm going to go find something to do for an hour. Glue's dry. Now we're going to test fit this trigger mechanism and put our screws here and here. See how this works out. But she fits. All right, now that that fits, I get some screws in there. We'll get the screws up on the limbs and see if this works. Just got back in the shop. Glue should be set up. I got the screws in. I'm gonna put the screws onto the fake limbs of this test piece, and then we're gonna attach some springs and test fire it and see how it holds up. So I have this assortment of springs. These aren't gonna give me a crazy amount of tension, but it'll be enough to test it. I'm going to start with 2 of these, 1 on each side, and then I'll link it up with a piece of string or something. I think that works. Although it'll be a lot heavier load when we get an actual bowstring and some real limbs, but trigger mechanism works. I don't know if I got lucky or I actually have skill, but that worked phenomenally. And hopefully I can translate this prototype into actual bow limbs on the final design. So that's what I'm going to be doing tomorrow. I'm going to be designing the body. I got to find some ash in the stock and thin it down to about 1/4 inch so that I can laser cut it. And that's going to be what I make my bow limbs out of. Hopefully this carbon fiber filled PETG filament is up to the task of holding 50 to 70 pounds of weight or of force. So we'll see. Since my goal with this build is to do everything either 3D printed or laser cut, I have to get a little creative when I'm making the limbs for the crossbow. So what I'm going to do is I'm going to create the shape of the limb if you were looking straight at it in Illustrator as a vector, and then I'm going to laser cut multiple copies of that shape out of thin ash, And then I'm also going to create a jig that has an arc to it. I just need to figure out the amount of arc I want, and then I will glue those multiple ash limb shapes together and clamp it to the arc so that we get that general bow shape. And then once that's all dry, I'm going to have a template that's going to sit on the top surface so that I can flush trim it with a router bit to give it a recurve shape. So I guess technically I'm using a non-digital fabrication tool by using a router, but there's really no way to avoid it with how thick the limbs are going to be once they're stood on end. It's just too thick to laser cut that. So using a template and a router is going to allow me to achieve that shape that I need. So I'm going to get to designing that shape and that template, and then we'll head out to the shop, cut these and glue them up. I just cut all of the blanks that I'm going to use for the limbs. So I've got 4 pieces of oak here. I've got 4 pieces of ash. So I'm going to laser cut the main shape out of them, and then I'm going to do a lamination with a form to get the curved shape to it. Now I have 4 bow limb laminations. These are pieces of oak that I laser cut, and I made this form that will give me the bend shape that I want in the bow limb. Hopefully this works like it does in my head. We're gonna find out. I just took the laminated limbs out of the clamps, and I actually shaped one off camera and tested it, and that didn't go so well, but I think that's because there was just a crack in this limb, but it gave me the opportunity to change how I shape it, and I'm about to do that with the ash one. So the oak one failed. I made some changes to where I'm shaping in on this one to leave a little more meat. I also shortened the length between both sides for the string, so it's going to take the pull weight down a little bit, but I think that's more than fine for this project. So let's get this shaped and see if I can get the string on it, and then we're going to move on to designing the rest of the project. So I just did a rough shaping on the belt sander, and now I'm going to use my handheld sander to do the finished shaping. I think then we'll be ready to see how this works out. The sanding, I think, is done. I might have to do a little touch up by hand just to finesse some areas, but the shape is pretty much where I want it to be. Hopefully this one goes a little bit better than that oak one did, but I think the changes that I made will at least make it functional. It may not be perfect, but it will be functional, I think. So now I just need to cut the notches at the end of the limbs for the bowstring. And I'm going to do that with the bandsaw.
I've got everything sanded and shaped, cleaned it up a bit, got my notches on for the string. Now comes the moment of truth. I'm going to put the string on this. I'm going to put this in one of my parallel clamps with the string slipped past the notches so it's shorter, and then I'll clamp it to give it some bend, hopefully without breaking this time, and pop those strings on and see how it works. And to be honest, or to be fair, the oak one didn't break putting the string on. I gave it a good tug after I got the string on, and it just failed at that point where I think there was a crack in the wood. Hopefully this doesn't suffer the same fate. Those notches are deep enough to keep it in. That one failed too. So back to the drawing board. I think I'm approaching this all wrong. So this was intended to be a laser cut and 3D printed crossbow build, which it has been. I think, and I guess I'm just rambling. The biggest problem here, I think, is I'm using a actual real store-bought crossbow string, and I just think it's creating too much tension for the material I'm using for the limbs. So in true laser fashion, I'm going to try something different. I'm going to laminate some 1/8 inch Baltic birch plywood, and instead of the actual off-the-shelf crossbow string, I'm going to get some 3mm nylon cord. It'll have a bit more stretch to it, so I won't have a high-powered real crossbow, but I will have something that's going to be fun for plinking with, and I should be able to pull it back without the limbs failing. So that's my thinking right now. I need to get some 3mm cord, and I'm going to throw my limb design into the laser and cut those laminates so I can glue them up. Since I already showed you the glue laminates that I did with the hardwood, I'm not going to bore you with that again. The concept's going to be the same, a little bit different though. So here's what I'm using. I've got 4 pieces of 1/8 inch plywood, and my scraps were at an angle, so the grain is running diagonal, which is probably not what you want for something like this. So I cut 4 of them. I'm going to alternate them so the grain will alternate. Second one, I've got 1 piece of 1/8 inch and 1 piece of 1/4 inch. Gonna laminate them together, see how that does. The 1/8 inch one again is the grain at an angle, because that's what I had size wise, and then the 1/4 inch, the grain is with the length of the limb. That's gonna be stronger, but not pull as easily. And then the last one I'm gonna do is 2 pieces of 1/4 inch plywood, both grain running with the length of the limbs. While I wait for the glue on those limbs to dry, I'm going to head back into my computer and design the body frame so that we can get those laser cut, so that we have everything ready once the limbs are dried to put this all together. So don't mind my change of scenery. I needed a break from my office, so I'm sitting in my living room, and I'm going to go through the components of the body of the crossbow that I designed in Fusion, along with some of the other components that attach to the body. So I'm going to show you in Fusion what I did and why I did it. So I started by creating a block for the front of the body, and this is designed to be made out of 1/4 inch Baltic birch plywood, or any 1/4 inch material really, and it's stacked like this so that it can be laser cut. So I've got the top and bottom plate here, and then sandwiched between that I have a T-shaped, let me show you. I have a T-shaped set of pieces that will glue together. And the reason I did the T-shape is the limb of the crossbow is going to attach to this block. And I wanted to be able to attach a nut
to the back side if I decided to bolt this on rather than screw it on. For now I have it screwed on, but as I change the limbs, there's potential for those screw holes to wear out. At that point, I would drill it out and put a bolt through, and this just gives me access to those bolts. Going on from there, we have the entire frame, which I'll unhide here, and this is made up of 5 layers laminated together. So let me hide everything except for the back. This would be the right side of the crossbow. We've got a cutout for the grip to inset. We've got a cutout where the trigger goes. We have a cutout for the limb block, and then this is where the bolt rail will sit. Then we will bring the next piece in, which is this. This is mimicking the same shape, except now we have a cutout notch for the trigger assembly to drop in, and we don't have our grip cut out because we won't need that anymore since this is further into the assembly. Next we will have the grip independently, and this leaves a notch for the trigger to drop in while still maintaining an area for the trigger assembly to mount. This is the same as that right piece that I showed you, and then we finally have the left side. So that goes together in layers. The 3 layers on the inside are made of 1/4 inch material, and the outsides are made of 1/8 inch material. That maintains, or that allows to keep the overall width comfortable in the hand while still having the rigidity we want. I just pulled all the frame pieces off of the laser, and now I just need to glue them all up, clamp them together, and hope everything fits. So I haven't drilled any holes yet, or mounted the limb, or designed the track that's going to carry the bolt to the front of the crossbow, but I just had to clamp this on just to get a feel for it, and that is awesome. You ever have that moment when you're making something or doing something and you're like, I think this is actually going to work? Well, that's where I'm at right now. I think this is actually going to work. The only thing that could potentially fail is if my limb cracks, because my lock point is like 1/2 inch further than the distance I tested pulling this back. I think it's going to be fine. And then the other thing that could potentially fail is if the material inside the trigger mechanism isn't strong enough to hold the weight generated by the bowstring pulled back. So that will be determined shortly. I also got some real crossbow bolts, I can't talk, from Amazon, so that you can do the real deal. Pretty cool. Let's go over the remaining 3D printable pieces that are going to go onto this crossbow build to bring it all together. So we already know all about the trigger assembly, at least this part. We've gone over that in full detail. This is a continuation of that V shape, which is where the bolt sits in and kind of keeps the bolt in a straight line. Then out front here we have a plate that sandwiches the limb between the block and this plate. And let me turn the limb on to kind of give you an idea. So that allows us up to 3 points of contact. When I assembled this, I actually left this screw out intentionally for now because I need to relocate this screw hole, but for all intents and purposes, it's going to be the same. So that's how we mount our limb to the frame, allowing us to change out the limb as we need. The next piece that we need for this setup is the grip, and that is going to be 3D printed out of either a hard plastic or a TPU, if I can get the TPU to print to my liking. After that, we have this guard that goes over the trigger, over the bolt release, and this the main purpose for this is to keep the trigger area protected, but also giving us an area to mount this bolt stay. And what this does is puts pressure on the bolt when it's in the cocked position so that it doesn't fall out. And then when you release the bolt, it throws it out, and this doesn't provide any this doesn't provide a substantial amount of resistance that the bolt can't come out. And then the last thing we have is the trigger guard, and this integrates with the grip and mounts to the bottom of the frame. Actually, I lied, there is 2 other pieces. So we've got limb block covers on the left and right. These are mostly just aesthetic to cover that void that's there, that's made by that T-shape. And then everything goes together with screws, and we have a completed crossbow. Finally, after hours of design, 3D printing, laser cutting, you name it, this thing is ready to put together. I've got all the parts here. Let's get it together and see if it works. And it is all assembled. Let's go fire this thing and see if it works. I've got a target set up in the backyard and we're ready to test this. Looking forward to seeing how this goes. I have high hopes that it's going to work well. And that worked phenomenally. I am super pumped with the results. It isn't super high powered. I'm not gonna kill any zombies with it, but it is a lot of fun for target practicing. And if I did some changes to the limb, I could probably get a little more power out of it. So what do you think? Was this a cool project? What should I try and make next with 3D printing and laser cutting? Let me know in the comments.